Hello, everybody. Thanks for having me here today. So yeah, I'm going to be talking about the river conditions and how they do affect us at the water treatment plants. So yeah, the City of Edmonton, we operate 2 water treatment plants, like Stephanie mentioned, in the City of Edmonton, Rossdale and E.L. Smith. Rossdale plant is right downtown, and E.L. Smith is upstream on the North Saskatchewan River in the Cameron Heights area of the city. We do serve about 1.16 million customers, and that's within the city and surrounding areas. We feed out to St. Albert, Sherwood Park, and we have a line that goes all the way out to Vegreville as well. So we do have a lot of customers along the way there too. This is kind of just a picture that kind of shows how we do treat the water. So we take the water, of course, from the North Saskatchewan River. We operate in 2 different modes. One of them is conventional treatment, and the other one's called direct filtration. And I'll explain kind of why that's important to know later on. But basically, conventional treatment is when we're using the clarifiers to do a lot of the actual treatment. We're adding a lot of chemical into the clarifiers. The solids that are produced will settle out in the clarifiers and as sludge and actually get sent back out to the river. And the clean water goes over onto our filters, goes through the filters, and we have UV disinfection after the filters, and at the end of the process we have chlorination. During direct filtration, we're using a lot less chemical. We're actually relying on the filters to do most of the treatment for us. But in order to run in direct filtration, it does require very, very clean river water quality. So there's only certain times of the year where we can actually run in direct filtration. But of course, when you're running in direct filtration, you're producing a lot less residual. So it's kind of our environmental commitment that we will run in direct filtration mode for a certain number of years, or a certain number of months in a year. The adverse river conditions. So what typically happens and what we're used to, we have spring runoff every year. We have the mountain runoff happening as well. And then we have heavy summer rain events. And all these do affect us and how we treat the water. What wasn't typical, in August, we had a very high river level event, and I'm not calling it a flood because we didn't actually flood at the plants anyway, and it brought with it very, very high color, which we'd never seen before. And what also wasn't typical is that high color stuck around right into the fall and into December. So that did affect us, and I'll kind of explain how. So starting with spring runoff, we're in spring runoff right now. We had a very, very busy week last week, and still it's quite busy this week. But typically what we see during spring runoff is the creeks, first of all, will melt, flush into the river, and when that happens, it brings with it higher color. We see higher color and we see higher turbidities. And then what we've been recently seeing is our ammonia going up, and we do have online ammonia color and turbidity analyzers, and so we do see those rise. So color will be 5 when we have before spring runoff during the winter, and it will go up to around 80. It can go higher than that. Turbidity will go from 5 till around 1,000 or so. Ammonia, which is usually at trace levels in the raw water, will go up to about 0.4 milligrams per liter. And this ammonia has been causing us a bit of grief over the last few years because it brings it's very, very hard to treat. So we end up using a lot of carbon to try and absorb the ammonia or these nitrogenous compounds, because we're not totally sure exactly what they are. We do know that our TKN values go way up. But we are only able to absorb it with carbon to a certain level. And what it means is at the end of our treatment process, when we add chlorine, these dichloramines form, and that's what gives us our chlorinous odors. Our swimming pool odors is what people refer to them as. And they're quite, we get a lot of complaints about those types of odors because they're not normal. So that is one thing we're seeing that's different. Also, like Stephanie mentioned, spring runoff is happening earlier and earlier. So this year, it did start the first creek flush, And it was, we monitor Strawberry Creek. Actually, Stephanie and her group goes out, and they have farmers out there taking pictures of the creek for us, because we know Strawberry Creek, when that flows, we're going to get these high colors, we're going to get these high ammonias, and it's only a matter of a few hours, before it actually hits our plant. So we do not like that creek. But yeah, so it is happening earlier and earlier. This year it was the Family Day long weekend, so February 24th or so, when we had that first kind of melt and flush into the river happen. Last year it was early March. The year before that it was early March as well, and these weren't happening until late March, early April. So it's difficult, because we plan on getting ready for spring and cleaning our plant and doing all that in in January and February, and of course that time has been shortened for us, so it makes it a lot more work for maintenance and operations, getting everything ready to prepared for spring runoff. And also, we don't like the surprises either. The first year that we had a very early March melt, we weren't ready for it, and we're trying to get our carbon system on, and we're trying to get our plants. Actually, we were still in direct filtration mode, so we had to get back in our conventional mode, because of course we just couldn't treat the water in direct filtration mode. And we had to put the plants, we're running the plants to bypass back to the river, because we can't treat that water in the condition that the plant was in. So it was, it was tricky and a bit stressful. Mountain runoff also occurs every year around June, brings with it high color, but usually a lot higher raw turbidity, and that's what causes the mountain runoff and melt. Turbidity can get has recently got as high as 8,000 NTU, which again, very difficult to treat. We do find it easier to treat than the really high colors that we see, but it is difficult, and it was 2014 where we had 8,000 turbidity, which was it was a lot higher than we had seen in the past, and so we're kind of getting used to those really high turbidities coming through as well. So August, yeah, I did just want to talk about August, because for us that was a very interesting, very stressful time. Alberta Environment did issued a high stream advisory on Tuesday, August 23rd. They called the control room at the plants, let us know that, you're going to see a rise of about 3 meters by the next day. Around noon the next day was kind of the prediction. So that was great. We topped up our chemical inventories. We know during these times turbidity is going to go way up, so we needed lots of chemical on site. We had to remove some equipment from the low-lift pump houses, and they sit right by the river, so we had to move those up so they wouldn't get damaged. Other than that, we thought we were in pretty good shape. We're not hitting flood levels or anything like that, and we're just going to have to manage through it. So what happened, the rainfall event was about 100 millimeters or more, centered on the North Saskatchewan watershed upstream of Edmonton. The river level rose 3.8 meters in 24 hours. And I'm sure you all heard about it. You couldn't go into the river valley at that time, walk down the paths in the river valley, because they were flooded, and there were lots of warnings on the news and that sort of thing about it. You saw logs floating down the river. The river was moving really, really fast. The crest hit Edmonton the evening of Wednesday, August 24th. The color peaked at 200 TCU. We'd never seen color that high before. And turbidity was about 3,000 NTU. So that's something we had managed through before. E.L. Smith, our bigger plant, which is in the Cameron Heights area of the city, remained online, but it was at a reduced production. We just couldn't treat that water very easily or very quickly. And it was touch and go. We kept losing the plant because we just couldn't meet our operational parameters. So it kept going offline and coming back online. Rossdale, we lost Rossdale completely. It was offline for nearly 28 hours. So that was a problem. Our overall storage volume in the city dropped to below 25%. So the reservoirs all out in the city were 25%. We like to keep those around 75%. When we have them topped up completely, we know we have about 2 days of storage left. At 25%, we weren't going to last too long, especially since we'd lost one plant and the other plant was kind of not functioning very well. So we did call demand management measures on Thursday morning. And that was, so we had water restrictions throughout the city. We were able to recover, though, through the weekend, and we were able to lift those measures on August 29th, on the Monday after the weekend. So this is kind of a snapshot of what was going on turbidity and color-wise for us. The blue line there is turbidity, and the red is color. So turbidity went up super fast, very hard to keep plants functioning and working well when turbidity is going up that fast. Color went up quite fast too, and it just did not stop. And so, as you can see, the turbidity peaked, then the color peaked, and then we had the river level peak. And what was nice, the turbidity came down really quickly, which is what we normally see with these turbidity, high turbidity events. But the color didn't. The color lingered, and it took quite a while to come down, and that higher color lasted right through the fall. And so this is just kind of our response to it in the control room. So the operators started increasing alum. Alum is the gray line, and alum does help us, is what we add to the clarifiers to, get the solids out of the water. And so they just increased alum up and up and up till eventually we couldn't increase it anymore. We're at such a high dose. And we realized that we're going to need carbon. We're going to need to turn the carbon on. And we've never turned the carbon on in August before, because typically we're using carbon in the spring to treat taste and odor. But we needed it at this point to help us treat the high color, because alum alone just couldn't do it. So we did start the carbon system. Of course, when you start a system that's been sitting unused for a while, you got to get things back up and running. It took a while for the carbon to make its way through the plant and start doing its thing. So that's kind of what happened when we lost Rossdale. We just didn't have that carbon on quick enough or high enough. And so that was a big learning for us there, that if we ever see the color going up as fast as it was and as high as it did, of course you can't really predict how high these things are going to go, but we'll just put the carbon on and try and ride it out. Sorry, the black line on this graph is showing what we did for carbon dosing there. All right, so this graph here shows peak annual raw water color events. The raw color is the red line on the red bar graphs on the chart here. The blue is associated turbidity during that time. And so basically from 1997 to 2016, the 2016 is the one on the far, bar graph on the far right, just kind of showing that we really hadn't seen color that high before. 135 TCU of color was the highest that we had seen before this event. And then, yeah, like I said, that high color just continued into the fall. So this chart here shows the raw color range in September from 1997 to 2016. And it just shows that 2016 really was an outlier year for the color range we saw in 2016 compared to those previous years. And then this is October from 97 to 2016. Again, it stands out even more here. We have a lot higher colors in our river water during that time. And then that's November. So again, it does stand out quite a bit. And that's from 1988. We did find data right from 1988 for November. So why is it so high? So we have a lot of theories, and I think you guys will know more why it's so high than I do. You're a lot more experts than I am, and I talk a lot to Stephanie and Mike about this sort of thing. But basically, we had a minimal spring runoff year in 2016. We didn't have, so when we had that high river event, maybe a lot of the organics and whatever was on the land really got flushed into the river during that time. The watershed was acting like a giant tea bag. That's something that Stephanie kind of was describing to me. We had a very wet, rainy fall, lots of fallen leaves and on the ground, and the forests were, there's a lot of moisture, and just all that kind of seeping into the river. That was kind of our theories on why the color just stayed so high for so long. And so Stephanie and her group did go out and do some sampling for us on some of the upstream rivers and tributaries. And this data set I have here, the samples were taken November 2nd. The Baptiste River had colors of 38, Brazeau Dam 15, and Nordegg River had 23 TCU. And again, typically in November, we're seeing around 5 TCU in the river. So with those contributing factors, that's why we're seeing higher river colors. So what did this mean for us? It meant that we had to use a lot of chemical to treat, which of course means a lot higher operating costs for us. Also, our chemical systems are working that much harder, our plants working that much harder, a lot more maintenance was required on our plants. We had the flock that was formed, so in the clarifiers, when you're adding the chemical, you're creating this flock, and you want it nice and heavy so it sinks and you can pull it out of the clarifiers at the bottom of the clarifiers. But it was light and fluffy, and this was due to the cold water temperatures during the time in the fall that we have. So that was just carrying over, that light fluffy flock was carrying over onto our filters and plugging up our filters. So we had to wash our filters constantly, and we had to really lower production through the plant. We weren't able to produce as much water through the plant. And we like to have shutdowns in the fall, so we can do maintenance on our plants. And we had to cancel one of those shutdowns because in order to have a shutdown, you have to top up your reservoirs throughout the city so that we have enough water so that we can shut down the plant for 12 to 18 hours. And we just couldn't produce. We were basically producing water as fast as it was being consumed. So we had to cancel the shutdown, one of our shutdowns in the fall. And then it took us, it was late by the time we were able to actually convert to direct filtration. So like I mentioned before, direct filtration is when we're using a lot less chemical. We're operating in that mode typically in the late fall and winter months. And we do need a raw color of less than 6. That's what we found in past practice to be able to run in direct filtration mode. Typically, yeah, we're converting in October to mid-November, and we weren't able to convert this year or last year right till the end of the year. So that is something that we try to do for our environmental due diligence, and it was just something we couldn't do last year. So basically, changing river quality definitely affects us at the water treatment plants. We need to use more chemical, and it does lower the production when we go through these adverse conditions. Spring runoff has been very challenging for us the last few years with the ammonia increases that we're seeing. And the high color events are particularly challenging as well. The river does seem to be changing to us just from what we're witnessing, color levels we haven't seen in the past, earlier and earlier spring runoff, this high river level flood event. Are we going to have more of those? I hope not, but I don't know. And high levels of ammonia, which I've kind of talked about. And carbon is the thing that kind of has saved us a lot during these events, but carbon is very, very expensive and not nice to use. Just this past spring runoff, this has been a really bad one actually. We used over $1 million worth of carbon in like a week and a half. So it's expensive, and it comes from Texas, and it takes a long time to get to us, so we got to really make sure we have enough inventory or we could be in a lot of trouble. So there's lots of stuff that we're trying at the plants. We need to think about, okay, should we have more inventory of carbon in case any of these events happen again? We need to plan our shutdowns during other times of the year so we're not, caught running out of water and trying to have a shutdown. Lots of things that we're talking about internally that we need to do differently. And do we need, I mean, if these things are, this higher color and that sort of thing is going to become the way of the future, do we need to add a new treatment process at our plant that can handle the high colors? Because it's difficult with the treatment process we have. It wasn't designed for such high colors. The turbidity it seems to be able to handle, but the color is very, very tricky.